Welcome back, students. Today we're talking about compounding and discounting. Now, the purpose of this video is to get you guys familiar with the concept of compounding and discounting, as well as what are their similarities and what are their differences and how are they related, okay? It took me, even me, some time to really understand the relationship between these two, and I really want to help students see this right at the beginning when they're learning about time value of money, because once you see this, you can't unsee it, okay? All right, let's go ahead and get started. So, simplify. You guys know I really like to simplify the concept as simple as I can, and then we'll grow on that concept, right? On that simplified concept. So, compounding. Compounding. When you see compounding, what I want you to think about is moving forward in time. So we're moving forward in time, okay? We're moving into the future. Into the future. Okay, that's why we call this, moving into the future value, all right? Now, discounting, I'm gonna use a different color, okay? We are moving backwards in time, but now very careful, we're moving backwards in time from a future value into the present, okay? Or the present value. So we're moving into the present. Into the present from the future, right? This reminds me of those Back to the Future movies, if you guys have seen that. All right, so very simple, all right? When we talk about compounding, I want you to think about growth. When we talk about discounting, I want you to think about moving backwards. But also discounting. I like this example of, let's say you go, it doesn't matter where. If you go to an outlet store, if you go purchase a car and someone tells you, I'm going to give you a discount. What is the first thing you think about? Well, I'm going to pay less, right? Here's the amount I was supposed to pay, but I'm getting a 10, 15, 20% discount. So you feel good because you're going to pay less, right? So discounting here is the same. You're ending up getting less of an amount, all right? That's a good way to think about that. All right, I have an analogy that I think will be helpful when understanding compounding and discounting, and I call this the snowball analogy. So forgive me for my drawings, but it's all I can really do. So let's say we have a hill, okay? I didn't like that hill. Let's say we have this hill. That's a much nicer hill. And we have a small snowball that we're starting off with, okay? Which I represent with $1. And we push this snowball down a hill. Now, as this snowball rolls, right, it gains speed and it gets bigger until it gets to the bottom of the hill and the snowball is quite large, right? So here we have, okay, this is the process. This is the process of compounding, okay? You can think of this process as the compounding process. Now, backwards, let's say we're at the bottom of the hill and we wanted to figure out the starting conditions. How small was that ball we started with? This is the process of discounting, okay? So I want to put this simplified analogy there for you guys to think of it in this way, okay? Now, let's get into the future value and present value formulas. What I have here on the left is the formula for future value, and on the right, I've got the formula for present value. So just like our snowball, we have a present value of, let's call this $1, right? Because I only put $1 marker here, right? We have a starting amount. And this term here, this term here is our growth. So of course, future value is going to be larger than present value, correct? Just given the fact that we have a starting dollar amount, right? We learned, let's just continue with our analogy here of $3. Okay. We have a growth that causes the present value to go from 1 to 3. Now for present value, notice that we have a future value. Okay, but we are dividing. So when you divide a number, you're actually making it smaller, right? So this is the term that causes the discounting that forces the present value to be smaller. Okay, stay with me. I understand, right? One causes growth, right? And one causes a discount or a making of that value smaller. Okay, I hope that's the best way I can put it, really. Okay, so let's do an actual example with numbers. I've kept the numbers very simple. Actually, for this you don't even need a calculator, at least for future value. So I've made it that simple. So let's go through our values here. We have $100 to invest today at an interest rate of 10%. Invested over 1 year. So let's solve for future value, but don't plug this into your calculator yet. Let's say you had $100 today and you're investing it for a year and someone says, I'll give you a 10% return. How much would you expect at the end of the year? $110, right? So our starting value is 100 times 1 plus the rate, right? The interest rate that was promised to us. But it needs to be in decimal form. So that's 10%. And T is the amount of time. So 1 year. So very quickly, let's just put that into our calculator. So we have 100 times 1.1, right? 1 plus 0.1 is 1.1. And then that's to the power of 1, but we don't need to do that. And that's going to give us $110. Okay, so $110. So this is the future value. Now, let's say you were told, hey, you're in the future, we're going to give you $110 and an interest rate of 10%. What's that $110 worth today? What's that worth today? The present value is like saying today. Okay, so we're going to take our $110 because that's now in the future. So we'll do $110 divided by 1 plus 0.10 to the power of 1. But of course, because it's the power of 1, we really don't need to put that into the calculator. So again, I have my $110 and I'm dividing by 1.1. That gets us back to our original amount, our present value of $100. Okay, so the purpose of this was to show you, right, future value, compounding growth, present value, discounting, right, backwards. So future value and present value are mirror images of each other. That's the point I'm trying to make also in this video. Now, let's do an example that's a little bit more, has a little bit more to it than $100, right? So let's say we are starting with, we have $10,000 to invest today at a rate of 8.5% invested over 10 years. That's not as simple. We have to actually put that in the calculator. So let's solve for future value. So future value is going to be equal to present value, right? Today, $10,000 times the growth. 1 plus, what's the rate? 8.5%, so 0.085. And the amount of time, 10 years, to the power of 10. Okay, so that's going to give us our future value But let's put that into our financial calculator. So we have, I'm going to start with this part first, okay, and then I'm going to multiply by 10,000. So 1.085, that's just the addition of these two, right, to the power y to the x of 10, okay, 2.2610, times, so this is the growth, times the 10,000. Okay, so 22,609.83 cents. Okay, now, you know what? I'm actually going to keep the 4 at the end just to get a little bit more perfect. So this is future value. Now, we want to take that future value in 10 years and move it backwards into the present and find the present value, right? So we're going to drop this future value. We're going to drop that into here to find the present value. Of course, we know the present value is 10,000, but I'm going to do the math to show you guys, right? So present value is equal to the amount in the future, 22,609.83 cents, and we're keeping the amount, and then 1 plus 0.085 for 10 years. Okay, so I'm actually going to use the store function. I'm going to store this value under the variable 1, so that keeps it stored. Okay, and then I'm going to take, I'm just going to recall this. I guess I didn't even do that. Divided by 1.085 to the power of 10. And that's not the answer I'm looking for. Why? I know what I need to do. So let's do 1.085 to the power of 10. Okay, that gives me my answer. I'm going to store this as 2. And then what I'm going to do is I'm going to recall 1 divided by recalling 2. And that's going to give me my $10,000, right? I needed to do it that way because, you know, I stored the top variable under 1 and I stored the value of the denominator under 2. So then it just made it simple. If there's an easier way to do it, let me know. But I think that's what I have found works for me. So you can see that these two terms actually get us back to $10,000. Again, compounding growth, discounting, moving backwards. All right, I got one more slide for you guys, so bear with me. I've got here the future value and present value, both in, sorry, not formulas. This should not be here. It's the timeline and the graph. So on the right, I have the graph, and it's very similar to the problem we just did. $10,000 compounded for 10 years at 8.5. So we're starting off with our $10,000. We're growing it, compounding for 10 years to get to the 22,610. I just want to show you guys how this shows up in the timeline when you draw a timeline, okay? So let's just draw a quick timeline. Here we have 5 years, and we have a total of 10 years. Just like I showed you guys in another video, our number of compounding years is 10. Our interest rate is 8.5%. Our present value is $10,000. And normally, like I've mentioned in the past, payments doesn't show up. So payments is 0. And we're solving for future value, which of course is 22,610. So just as we can move forward compounding, we can move backwards. A different color. We can move backwards to the $10,000 by discounting. Similar here, moving forward in time is compounding, right? Moving backwards in time is discounting. Okay, I hope that I hope that's clear. I really try to do my best to simplify this concept so that you guys can get a clear picture of what these two very, very important terms in time value of money actually mean. All right. So I'd love to hear from you. If you have any questions about time value of money, anything that I can help with, I would be more than happy to. And if not, I hope to see you guys in the next video.